Good afternoon. My name is Xavier Ducrohet.
And my name is Jerome Dochez.
So today we're going to talk about what's new in the Android build system since last year. We're going to start with variant-aware dependency management. So it shipped last year in 3.0 in the fall, and the whole concept is that all the variants of a module can depend on matching variants in another module. So debug depends on debug in a library, and release depends on release. And it works well as long as you have matching variants on both sides. But when it doesn't happen, even though we have a DSL to help you fix the problem, but we've seen a lot of developers over the last 6-9 months who just see an error message, like this, and just don't know what to do with it. So we wanted to take a few minutes to explain exactly what's going on and help you solve such a problem. So the first thing to look at is there's this line that says could not resolve project library. So that's the project that publishes artifact that you're trying to consume. And the project that's consuming it is the one that says required by project app. And in the top right section, you can see it says, the name of the configuration that we're trying to resolve, which is staging runtime class path. And it's always the name of the variant, followed by compiler runtime, followed by class path. So here it's the runtime class path. And the error is, unable to find a matching configuration. And so the way it's working really is that the library project is publishing a whole bunch of artifacts for different variants in different configuration. And each of those configurations has attributes associated with it so that Gradle can match it. On the app side, the request has similar attributes, and it's trying to do a mapping, and it needs to find one exact match. And here, it can't find any match. So if we go through those 4 configurations, you can look at all the attributes and basically, by process of elimination, find out what the problem is. So here, the first thing that we see is 2 of them have an API, the API used by compile class path, and the other 2 are runtime. And you can see that the attribute named usage, we request Java runtime, and some of them are using Java API, so they are not compatible, so we can just ignore them. Then we have a few more attributes. There's one here, Android type attribute, that is compatible, so on both sides, so we can just ignore it. It's something that we use internally to match different type of plugin application versus library versus features, so you can just ignore it. The other one, variant attribute, is not required. It's actually never required, and you can just ignore it always. We use that only when we build the model, when we do a studio sync, so you can always ignore it. And then we find the final attribute, which is always incompatible. We ask for staging, and it's finding 2 other values. And the name or type of the attribute here, which is package name.buildType attribute, is the key part. It's basically, hopefully, self-explanatory. This is the build type attribute, and we're requesting staging, and it's not finding it. So basically, it means your library does not have the staging build type, and that's why it's failing. So you can create it there, or you can just use the DSL that allows you to create a fallback. So in that case here, in the app, you're saying, if staging is not found, just use debug. You have the same exact principle if you have a missing flavor dimension value. Here, the error message is a little bit different because there's multiple flavors potentially, so they're named, tier being the name of the flavor dimension. But that's the same problem, right? It's not finding trial when you're searching for it. And so the fix is basically exactly the same one. You're just assigning matching fallback on the trial one. And you do that on the consuming side, right? On the app side, not the library. Or if it's a library that depends on a library, you put it always on the consuming side. You can have another type of problem. Here, it's saying cannot choose between the following configuration, right? So instead of finding 0 matches, it finds 2 compatible matches. And so, it's only going to show the 2 configurations that are matching. It's going to hide all the other ones, so that's a little bit easier. And if you look at it, there's going to be a lot of attributes that are compatible, so you can just ignore them. And then you're down to those 2 here, and it says it found an attribute on the producing side, on the library, but it was not required by the consumer. And so here, basically what's happening is that your library has defined a flavor dimension that is not used, or not defined in the app or the consuming module, and therefore it doesn't know how to choose this one. So you can, again, create the flavor dimension in your app or in the consuming module, or you can just go and say, missing dimension strategy, name of the flavor dimension, name of the value, and all it's doing really is just adding that attribute directly to the request so that it's able to match the other one. And you can add this either to the default config, which applies to all your variants. You can apply it to a specific flavor, which will apply only to that flavor, or you can add it to a particular variant.
Thank you. All right, so let's talk about some of the notable changes that we've introduced in the compilation pipeline. The first thing that we have changed lately is AAPT2. And this is a new incremental resource compiler. And compared to AAPT1, AAPT2 is really dividing its work into two phases. There is an incremental capable compilation phase where it's changing your resources into a binary format. And then there is a final linking phase where it's going to generate the resource table and the final IDs. Now, if you want to use the latest platform features, you need to use AAPT2. And in theory, AAPT2 is entirely compatible with AAPT1. However, it's a lot stricter. So you might run into issues when you change from AAPT1 to AAPT2. So we have given you a flag so that you can disable if you have issues, but you should be aware that those issues may not be in AAPT2 itself. It may be in your project. So you should file bugs if you find issues with AAPT2, but you should do your homework first. You should look into, well, maybe the problem is in my project. So let's look, maybe you have invalid resources, unreferenced stuff. AAPT2 will catch those. So we're going to phase out AAPT1 pretty soon. So it's really important that you switch and that you file bugs if you still find some. Next thing is dsugar. So this is a tool which is used to remove all the syntactic sugar that was added by Java 8, like lambdas and stuff like that. We've delivered, again, into two different versions. So the first version, which shipped with 3.0, was an external process. It used a lot of resource, was pretty slow. Now, with the D8, the new Dexter, we've introduced a newer version where it's integrated inside its pipeline. So it's better, it's faster. Again, we're going to phase out the old version. In theory, you should all be switching to the integrated version. You shouldn't be seeing any difference. If you do, please file a bug. It's most likely our fault this time. It's probably not your fault. But file a bug, because we're going to phase out the old external process version very soon. Talking about Dexter, you should all be using the new D8 compiler right now. It was introduced in 3.0. It's now default in 3.1. If you use DX, if you still use DX because you have errors, translation errors, or runtime errors, you should definitely file bugs. They are extremely responsive at fixing those issues. And again, we're going to be phasing out DX, the old DX, very soon. And we would like you to be still capable of building your applications, so please file bugs. Now, we've just introduced R8, which is a new shrinker obfuscator. But it's a slightly different thing than what it used to be with ProGuard. So ProGuard used to operate on class files. It was transforming class files and making them minified to be ready to be dexed. R8 takes over the entire pipeline from class files to dex files. So that means it's doing dsugar, it's doing minification and dexing, all in one operation, and it can reuse a lot of the data, so it's faster. So when we introduced it, you should try it, and you should see if it works well. Again, please file bugs, because at some point, we will stop supporting the old shrinkers. Maybe not soon, but very midterm, I would say. Now, these are the flags you can use to enable or disable R8 and D8. So please use this if you run into trouble, but please also file bugs, okay? Now, let's talk a little bit about performance. We know very well that it is a subject that you are extremely interested in, and so are we. One of the problems we have is that we have a lot of trouble reproducing issues that may happen in the wild. We don't have that many implications internally that we can use. So, however, here is an example using the Nest mobile app. And you can see that a Nest full build has improved about 13% from 3.0 to 3.1 and about 18%. Obviously, this is not final with 3.2 versus the 3.01. That's if you keep the same set of features in your application. Obviously, you're not changing the application, just changing the plugin. If you start adding features like Java 8 or Kotlin, things may vary, obviously. Now, if you look a little deeper at performance, things is a little bit more complicated. So in particular, when you look at incremental builds, you can see that Java-C for the full build was about 10 to 15% of the overall build. But when you're in incremental build, it jumps to a really bad 38% of the overall build time. So really, we can see that in incremental scenarios, Java-C compilation is the dominating factor. Why is that? It's because it's not incremental. Why is it not incremental? It's because people are using annotation processors. And so far, they are not incremental capable. So we started a joint effort with Gradle to have incremental annotation processors. It's called InCap. So it's ready. It's been shipped in 4.7. And now we are in the process of trying to move all of Google's annotation processors to be incremental capable. There is an action required from you. If you have in-house annotation processors, then you should move them to be in-cap capable to use this library. It's not very complicated. For the simple annotation processors, where there's just like one source file and it generates something from one source, doesn't need to see the entire world. It's just adding a few manifest entries, so it's very simple. And that will eventually, if all of your annotation processors are in-cap capable, we'll be able to switch the compilation to be incremental, and that will have a huge impact on the performance of your incremental builds. Thank you. Let's talk a little bit about Jetpack. You've heard about it a lot, so how does it work? Let's just take the first example where we have a pure, you want to move to a pure Android X project. So here you've got your old project, it's using the old COM Android support. What you should do is to use the refactoring tool in Studio to actually move your project to use the new stuff. One of the issues is that we add some dependencies to your project automatically. Say you use legacy multi-dex, say you use data binding, we're going to add automatically the multi-dex support library. Now, if you move to a new pure Android X world, where you now suddenly have the Android X constraint layout instead of the old com.support, we need to know that we must use the Android X multi-dex runtime library so that the two worlds do not collide, right? So we need to have an indication of which one we want to inject. And you need to tell the plugin, this is, through this flag, which of the two versions you want us to use. Okay, so if you want to move to an Android X world, please use this flag. If you are in a hybrid world, which is most likely what's going to happen to most people, so yes, you've moved your application, you moved all your projects to use the new Android X stuff, but you use some external library that you have no control over that still uses the old com.support libraries, you have no choice, you have no control over the sources, so what can you do? So we're going to provide a build time translation facility that will just basically change automatically the dependency from the old com.Android support to the new one, and will change the library itself by changing all the import statements to the new ones. So this is done locally. It's not like we're going to republish this library, but locally you will be able to have an illusion of a pure world where everybody is depending on the new Android X library. Again, there is a flag, enable Jetifier.
Okay, so let's talk about the app bundle. I'm sure you've heard about the app bundle a lot over the last 2 days. So we're going to tell you a few Gradle specific things. So the first thing is that on the application plugin, not on the library or the feature plugin, but on the application plugin, on top of all the assembled tasks that you see here, we have bundle tasks. And so you'll be able to very quickly, without any change, just go and build a bundle, right? And remember that the bundle is a way to upload that to the Play Store and get out of the box much smaller APKs targeting ABI, density, and languages, for a specific device. So you'll get much smaller install. Locally, you can also build an APK exactly the same way the Play Store does it when it creates those APK. So if you want to verify something, saying, I have a device, I don't want to build an APK directly, I want to build an APK the way the Play Store would create an APK from the bundle, you can do that. So the step is definitely a little bit more involved than directly building the APK, right? We first build a bundle, then we use a tool called Bundle Tool, which is also available as a command line tool. to create a zip of all the possible APKs. And then based on the device configuration, we can go and create those APKs. In general, we don't really necessarily want you to create that manually using a Gradle task. However, a lot of Studio and Gradle itself can use that flow when you need it. So for example, the install task, if you have just a basic Android application with no dynamic features, is going to directly build an APK. As soon as you create dynamic features, which we'll talk about in a little bit, then the install task will go through the bundle in order to ensure that we can install that on any device. Because remember, if you have a dynamic feature and you try to install on a pre-L device, so API less than 21, we need to fuse that those APKs together in order to install it. And we don't want to do it a way that's different from the Play Store. We want to do it exactly the same way the Play Store does it. If you try to run tests from the command line calling connected check, it's always going to go directly to the APKs. We're going to work later on adding support to run tests via the bundle in order to simulate better exactly the type of APKs that are created by the Play Store. Deploying from Studio, you have a choice, right? You can either directly deploy APKs, or you can deploy APKs built via the bundle. And here, the run configuration inside Studio has a checkbox that you can check. We recommend to not check it when you do your regular development. As we saw earlier, building a APK from the bundle is much more complicated than building it directly. And on top of that, when you deploy from Studio, we actually look at the device you want to target, and then we inject that information into Gradle, and then Gradle takes some shortcuts. So for example, if you require legacy multi-dex, which takes a while to build, but you deploy to a device that's 21 or above, we're actually going to use native multi-dex, which is much faster. We can't take that kind of shortcut when we build a bundle, so we recommend to have two different types of run configuration. Just create two of them, one with and one without the option, and then use the APK as often as you can, and only use the other one when you really have to, when you want to try exactly the APK that would be delivered by the Play Store. If you push to a device again that's pre-21, then we're going to use that option anyway, and we're always going to go through the bundle as soon as you have dynamic features. So you may already be doing manual multi-APK using that DSL, and also there's a variant API that allows you to compute version code dynamically for all the different APKs that get generated. If you're doing that right now and you want to switch to the bundle, you can just erase all of that DSL. It's completely unnecessary, right? There's nothing to do. All you have to do, you call the bundle task, get your bundle, you're done. And on the server side, we will do all the split by density ABI language by default. We do have a DSL to allow you to maybe disable it if you're running into a problem. We expect that there will be very, very few cases where you actually need to do that. But you have the ability if you really have to. If you have that, also file a bug and talk to the Play Store team and see if you can actually solve the problem with them. So I mentioned dynamic feature earlier. So what are dynamic features, right? They're small APKs that are downloaded on demand side by side with your main APK. So if you have a feature that only 10% of our users need, no need to install it for all the other 90%, just have it downloaded on demand. So the way you're going to organize your code is it's a separate sub-project in Gradle. You have a different plugin, a new plugin called dynamic feature. And the layout is a little bit different compared to, let's say, a library, right? Normally in a library, your application depends on your library and can refer the code of the library. Here, the features are actually sitting on top and depend on the base. So we can see here the two base feature, the two dynamic feature in blue, apply the plugin dynamic feature, have a dependency on the project app, which is your base one. Now the base one also have to refer to those dynamic features. It needs to list them because the way we build the, I'll show you later. It's a little bit complicated, it's unusual. But you need to list those dynamic features, and it's just a list of strings which are the Gradle path of all of your dynamic features. If you used Instant App since last year, it probably looks somewhat similar. Instant App, you have the feature plugin, which is used both for your features and for your base feature, except you have a small flag using base feature equal true. But the base feature also have to refer to all of those features using a slightly different DSL, which is not great and will probably migrate to the dynamic feature version soon. But right now, you do it using the feature configuration. And you probably heard about then in the future you'll be able to instant enable your app bundle in order to deliver dynamic apps using the app bundle. And this is why it's going to be possible, because the feature plugin and the dynamic feature plugin are very, very similar. In fact, the application, dynamic feature, and feature plugin share probably over 95% of their code. They are extremely similar. And so if you're already architecturing your app for instant app, switching to the app bundle would be exactly the same architecture with slightly different plugins. And if you're doing dynamic feature right now, then also enabling that to be instant app will be very similar in the future. Okay, so I mentioned that bidirectional dependency, where the app bundle needs to know about the base app needs to know about the feature. So if you have those two modules that I had before, if you're building the APK, it just look normal, right? There's a bunch of intermediates in each module, and each output an APK. What happens is that the bundle task belongs to the app bundle, to the app module. And so when you actually build the bundle, we have to publish things from the feature back into the base module, and that's why we need to have all of those dependencies be available on the base module. If you don't add a dynamic feature to your base module, it's just not going to happen. It's not going to show up in your bundle at all.
So when developing dynamic features, it's important to understand there are some differences with traditional Android application building. So in particular, there's some attributes of your application which are invariant, which won't change between the base module and the features. Application ID, version name, version code, all of those should be set in the base module, and we will then publish them back to the features so that they can be used in the task when, for instance, generating the manifest or whatever. So it's important to understand that you set them in the base, you do not repeat them in the features, we will automatically transfer them, okay? Let's talk a little bit about multi-dex. So let's say you're in a multi-dex situation and you're not using any features, but you're still doing the bundle thing. In this case, there's really not much difference. It's the same behavior. The only difference is that instead of shipping stuff into an APK, we are now shipping into a bundle, which eventually gets uploaded. The dynamic delivery will not do much. They will just take these dex files and store them on the device before execution. So same behavior. If you have feature, still not a lot of difference. Basically, each feature can develop and grow, can become itself a multiple dex files. Everything gets merged onto the base module, and then you get all packaged inside the bundle again. And same thing as without feature, it gets delivered on the phone, not a big difference. By default, we enable the native multi-dexing. Now, things get a little bit more complicated if your main SDK is below 21. So if it's below 21, we need to have flexibility to still deliver the application in native multi-dex if you are suddenly deploying on a device which is 25. But if you're deploying on 15, now we need to do something specific for that. And what will happen is that the dynamic delivery will fuse all of your dex files into a single one that will be delivered. So this is important to realize that even if none of your modules, including the base module or your feature modules, if none of them use multi-dexing itself, because we combine those into a single one, this may actually go over the dex limit, and this may require multi-dexing, okay? So you need to manually enable multi-dex in the base application. And what that will do is basically create the men's dex list that it will ship along with all the dex files into the bundle. So now the dynamic delivery will take that bundle, and it will be capable that if suddenly you're trying to deploy this bundle on a 15 device, it will use the mendex list to do the fusing, create the correct mendex, and then create the extended dex correctly. All right? Shrinking and obfuscation. So it's the same as before. You set it on the base module, just like the application ID. So you say minify enabled. This is not a lot of changes. But how we actually implement it is really, really different. So let's go through the motion here. First of all, this is only supported with R8, which is our new shrinker I talked about earlier. So what we do is that we take all the rules that will be defined close to the classes they apply to, so all the rules in the features, we will merge all the rules into a single one. Then we'll take all the class files, we feed this into R8. R8 will create a combined dex, big dex files with everything. And then we're going to feed that dex file into a dex splitter, which will resplit this dex for all of the features plus for the base. Right? So it's a very different mechanism as before. Now we have, again, this dex is been shrinked, it's been obfuscated. Now there's two scenarios possible. Either you're using the bundle or you're using the APKs. If you're using the bundle, it's pretty simple. These dex files are automatically transferred into the bundle, like we saw earlier. If you're using feature, it's slightly different. The dex files need to be republished back to each of the feature, and then they will be packaged into the APKs. All right, so it's a slightly different mechanism as we must have seen in the past. There's a lot of going back and forth, and that's why we need to have these dependencies between features and app.
Okay, so we wanted to talk a little bit about a few things that are actually not shipping in 3.2. We are working on it. We've been working on it for a while. We expect they will ship soon in a 3.3 canary, and they have a lot of changes, and so we wanted to kind of like give you a heads up, and also we want feedback as soon as it's available. So I want to talk about the way we process resources right now in the build. So if you have a first library called library 2, in the current flow, what happens is that we're going to process those resources, and we're just going to generate an r.java and nothing else. So when this gets consumed by another library, library 1, this one may be referencing resources from library 2. And so in order to really validate all those resource references, and also these with some overlay mechanism, we're going to merge those two resource folders into a single resource folder and process it, and then generate another R class. We actually generate two R classes, right? One is for the library itself, library 1, which contains all the resources from library 1 and library 2. And then we have another one, which is just a new version of the R class generated by library 2 that is used in case you want to run tests and things like that. You need the final ID version of it. So then if that gets consumed by an application, we kind of have to do the same thing again. So we're going to remerge the app and library 1 and library 2 and process all of that. And then we generate the final resource binary format, as well as all the final R classes that are needed by the code from the app, library 1 and library 2. So as you can see, this is not exactly efficient, right? You know, this is probably one of the last things that is very inefficient in the way we build things. The resources from library 2 is basically merged and processed 3 times. We generate a lot of our classes. In fact, we're seeing some project with a few hundred modules generating several thousand R classes, which is too many. And so we really need to solve this. So as I said, we've been working on a new flow, and this is what the new flow looks like. So first, when we compile the library 2, we're going to generate a binary version of resources. And this is because APT2 has that feature. We can't make that work with APT, so that's why Jerome was saying APT2 is going away. AP2 is really the future. We also create the R class, and this time we just generate the R class directly rather than the source code so that we don't have to compile it. That's more efficient. When we depend on it and consume it in library 1, what we're going to do is that we're only going to process the resources of that module. And then we'll use the output of the previous module the same way basically you use a jar during Java-C, right? It's just a compiled class path. It's mostly there to validate, again, resource references, and we generate a new resource package that only contains those resources, not the merge version. There's no merge anymore. And the R class only of that library. Now, that library, R class, only contains the resources of that library. It does not contain the resource IDs of the previous library and this one. We don't merge those IDs anymore. When an app depends on library 1 and library 2, same exact principle. At the end, we have an additional step because we need to take all those binary and those binary format of the resources and merge it into the final one and create the final R class. So as you can see, we are generating a lot less classes, and also it's a lot more efficient. For example, if I change a resource in library 2 by just editing, let's say, a string, there's no reason that I need to compile library 1 again, right? It's just the list of IDs that I need to check against for reference is exactly the same one. There's been no changes. So we can use the same thing like compilation avoidance that we use for Java-C. And then we don't need to recompile library 1. We don't need to recompile the app as well. All we have to do is do the final link, and that's it. And we can do that also because the R class for the app does not use final IDs anymore. So let's look at some of the impact of that change. So first I said that the R class of each module only contains the resources of that module. It doesn't contain all of them. That means that if you're inside a module, you want to reference another resource from another module, you have to use the R class from that module instead of the R class of your app. That means you're likely to have to import more than one R class, which Kotlin solved easily with type alias. We are looking at ways to also make that work in Java easily because technically there's no reason for the R class to be called R. It could be called whatever else. So each library could define its own name to reduce the amount of conflicts. And again, as I said, the R class IDs are not final anymore, even in the app, similar to inside libraries, which means that you can't use Java switch cases anymore. I mentioned we are not doing resource merger anymore. So if you have a module that redefined a resource already present in a library, that's not going to work anymore. And there's some good reason for that. We definitely want to hear from you if you're using that in a strange way. If what you're doing is, well, in debug in my app, I want to override an icon that's coming from one of my library, you can just use variant-aware dependency management, right? In that library, have a debug version of that icon, and then the app will consume the debug version anyway, which was not the case before 3.0. So that solves that problem. If you have another use case, definitely talk to us because we want to hear about it. So I mentioned namespace, right? I haven't talked about any namespace so far. But when you think about it, I just said we don't have any resource merger or resource overlay. So what happens is your application depends on a third-party library here or a third-party library here, and both of them declare exactly the same resource with the same name but with a different value. A string maybe, or layout, or an icon, or something like that. In the past, the resource merger would just pick one of them, basically. The first one that you define in your dependency would have a higher priority, and it would just merge on top of the other one, and it would just replace the other one, which is probably not what you want. And so here, what's happening now is that what we really want to do is we want to package both of them. So both of them are going to be compiled in their own namespace. And then we're going to package that. Internally, the R classes from those two libraries will have the same, r.string.foo, but with different values. And internally in the resource table, they will really point to two different resources, which is much better. So now when you reference to a library, to a resource from a library, you have to use the namespace of that library. And using the R class of that library is already a way to access it via its namespace, right? It's like you don't have a single R class with all the IDs. So when you do that from the manifest, it's a little bit different. You have to use the manifest, when you use that from XML, you have to use the namespace directly in the resources. So at com.library1:string/text, which is very similar to when you access an Android namespace resource, right? At Android : something. If you do have custom attributes, you have to do the same thing. So you're probably using res auto everywhere now, not really bothering what your namespace is. Now you actually have to care. You can say, hey, this is constraint layout. This XML prefix constraint is that namespace of that library, and then I can use those attributes. So we're hoping to bring that in 3.3 Canary. It's going to be opt-in, obviously, some breaking changes. We're going to enable that with a flag. We're going to include refactoring support in Studio so that all those references will be changed for you. And we're going to want a lot of feedback, right? It's not going to be turned on in 3.3 final by default either. There's going to be several revisions where there will be changes and improvement, but we'll want a lot of feedback.
Thank you. OK, last thing we want to talk about today is our public API. We are painfully aware that the public API that we provide is not very good. It has no very poor documentation. The plugin DSL is pretty bad. It's not specific to the module type. So there's plenty of things you cannot set in different modules, yet the DSL is still there. There's no mechanism to access the intermediate files. So some people would like to have access to the merge manifest, class files, dex files, you name it. You can't really do it in a nice way. The variant module doesn't give access to a lot of information coming from the variant properties, so you only have access to part of the truth. And then there's just too many things that require internal APIs, hacking tasks, the separation between public and internal APIs is not well defined, so you don't know when you're switching from one to the other. So it's a mess. And to give you an example, this is how the configuration works today, right? So we have the DSL parsing first, and then we create the variant, right? So that bunch of variants are created. Then we create all the tasks for all of these variants, and eventually we call the variant API. So that's where a lot of the scripts, customization scripts, are running. But you can see here the problem is right there, is right in front of you, that it's happening after the tasks have been created. So there's no way you can change anything that will influence tasks creation. Say you want to switch from legacy multi-dex to native multi-dex, but you can't do that anymore because we've already created the tasks for legacy multi-dex. Say you want to change some of the information in the DSL programmatically instead of putting it in the DSL, well, you can't really do that either because we already created the tasks, and chances are that the input have already been finalized. So it's happening too late, and then eventually the after evaluate scripts, the custom ones, run even later. So there's really no way you can do a lot of things here. And so what people do is that they access the tasks, and then they try to figure out where the files are generated, and it's a mess. So what we would like to do is to have a simple Gradle API interfaces that would be the only module that you should depend on. And if you start depending on some of our other modules like Gradle Core, you should talk to us and you should tell us what are your needs, why are you doing this. Don't think that we are not listening. We are interested in figuring out why you need to customize things, and we are interested in providing you a good solution. So one of the things we are looking for instance, is to give you access to all of the intermediate files. So each intermediate file really is associated with a type, right? You've got classes, you've got merge manifest, you've got dex files, you've got resources. All of those should be able to be accessed and should be safely capable of being replaced. So you should be able to say, give me the merge manifest, change it a little bit, and I'm giving you back this new version. And that's the one you should use to continue the build process. So it should be replaceable, it should be appendable. Maybe you want to add class files directly. And eventually, all of this should be done through very well-defined extension points. So we started working on it, and we would like to have feedbacks on this. So the proposed phases would be slightly different. Now you've got the DSL parsing. We would then start invoking your custom code right there. So you would have the ability to start changing DSL objects programmatically, even before we start creating variants. Then we would lock them up. That means you can't change them anymore. Once that code has run, it's locked up. We would then create the variants from this information. From the variant, we can then call directly the variant API. So that's the ability for you to change variant-related information. Now, be aware that this is happening now before the task's creation, right? There's no task created yet. So this is really the ability to say, it was using multi-dex, now I want it to use legacy multi-dex. Once these variant API scripts have run, we will lock up the variant object. So again, if you use scripts later on, like in after evaluate, that starts to change the DSL parsing or the variant, it's too late. We will not allow it. We will throw an exception. Then eventually we create the tasks, and we will lock them up immediately. We will not allow you to modify the tasks anymore. The way to modify things will be to go through the buildable artifact, to inject, to replace, to append, but not mocking with the tasks, because we replace them all the time. We merge them, we delete them, we split them, whatever we need to do to support new features or make things more efficient. And then eventually the after evaluate will run. So the compatibility will be a painful subject. We will try to make, obviously, the DSL mostly unchanged. We're going to try to make an effort to also becoming more Kotlin friendly. And unfortunately, we think that the variant API will change heavily. But since we already realized that it was not so great, hopefully you'll be sympathetic to the idea that you will have to change the script using the variant API. So we want to hear from you. It's very important that we get feedback from the community for us. And I want to thank you for coming tonight. I know it's a late session. It was very nice to see so many people here tonight. Thank you.
Thank you.